In this lecture, we will continue our discussion on merge sort.
In the last lecture, we introduced the merge sort algorithm, or at least we talked about the process of merging two sorted lists. We should mention that the time it takes to do this merging is linear, and this is because we have at most n-1 comparisons when we take the elements of both lists and put them into the larger list. And here we're saying that n is the total number of elements from both of the sorted lists. So let's take a look at the complete algorithm, and it's actually pretty straightforward. So let's suppose that n is 1. Well, that means we only have one element to sort, so it's sorted by default. Now let's say the list does not have just one element, there's more than one thing. So what we would do is apply the merge sort algorithm to the first and second halves of the list. So we'll take the list or the array and we'll split it in half, and for both of these halves, we'll apply the merge sort algorithm. And what's going to happen is eventually, if we just keep repeating this, we're going to get two sorted halves, because what we're going to do is we're going to break it up with the array into two halves, and then for each of those halves, we will break it up into two more halves, and then break it up into two more halves, and eventually they'll get down to just one item. So then they'll be technically sorted. So then we'll merge the sorted halves using the merging algorithm. So we'll take all the elements, or the arrays that have just one item, and merge them into arrays of two items. And then those will be sorted. And then we'll merge those arrays of two items into four items, and so forth. Now, there may be some cases where we have an odd number of items in the list, but that's not a major issue. But the whole point is we're going to break up into smaller parts. We get down to one thing, we merge them, and they become sorted, and keep merging them into more and more sorted lists until we get back to the original problem where we would merge the two sorted lists and get one giant sorted list. Let's walk through an example of the merge sort algorithm just so you have a better idea of how this works. So let's say this is our array. So here we have 8 items. Since our array has more than one item in it, we'll split it up into two halves. So now we have two arrays where both of them have 4 elements each. We'll now focus on the left array and get that completely sorted before we do the right array. So since this array has 4 elements, which is more than one, we're going to split that array into 2 more arrays, but each of those would be of size 2. We'll now focus on that left subarray, so the one with 24 and 13. Since that array has 2 items, we're going to split that up into 2 halves, where each one has 1 element each. Since both of those arrays, the 13 and the 24, were 1 element each, we say that those arrays are sorted. So then we apply the merge operation to merge those two arrays to a sorted array. So now we got 13 and 24 as our merged sorted array. We'll then look at the right subarray, the one with the 26 and the 1. So since that has 2 elements, we're going to split that into 2 arrays with 1 element each. So that means that we have 2 arrays with 1 element, which means both of them are technically sorted. We then merge those two sorted arrays to get an array of 2 elements that is sorted. So we see that we have 1 and 26. We then merge the 2 arrays with 2 elements each. So we had the 13 and 24 for one array, the 1 and the 26 for the other array. So we merge those two together to get the sorted array 1, 13, 24, and 26. So now that whole left subarray is sorted. So now we can focus on the right subarray. Since that array has 4 elements, it's not 1. So we're just going to do the same thing where we break that up into 2 halves. So we have 2 arrays here, one with 2 and 27, the other one with 38 and 15. We'll then focus on the left subarray, the 2 and the 27. So we'll split up that array into 2 arrays with 1 element each. And since both of those are of size 1, we say that those 2 arrays are sorted. We'll then merge the 2 and the 27 to a sorted array, which gives us the array 2 and 27. So here it really didn't make a difference since they were already sorted, but we still have to follow those steps anyway. We'll then focus on the right subarray with the 38 and 15, so we'll split those up into two arrays with one element each, one with 38, one with 15. Since both of those are size 1, we say that those arrays are sorted. We then merge those two arrays together to get the array of size 2, so we get 15 and 38 for our sorted array. We then merge those two sorted arrays, so we had 2 and 27 for one array and 15 and 38 for the other. So we merge them into an array of size 4 that gives us a sorted array. So we have the 2, 15, 27, 38. So now the right subarray here is sorted, and since we have our left array being sorted, we can now merge these two sorted arrays to get the final sorted array. And here's the result of merging those two sorted arrays. I think we mentioned this term a little bit before, but the merge sort algorithm is a classic example of what we call the divide and conquer strategy. So with the divide and conquer algorithms, there are two parts, the dividing and the conquering. So the dividing part is where we take our problem and break it up into smaller and smaller problems. So what we saw here is we took the array and broke it up into two halves, and then we broke it up into two more halves and broke it up into two more halves and kept doing that until we can get a trivial solution. So then the conquering portion of the strategy is patching together the answers. So what we did is we broke it down until we get arrays of size 1. We say those are sorted, so we merge those sorted arrays to get new sorted arrays of larger sizes. And then we would merge those sorted arrays to get even more sorted arrays. So then when we're done with all the merging, we would have a complete sorted array.
Let's now take a look at the code for implementing merge sort. Now, with this one, we just have everything in one file. We don't have a class file, then a client file. You just have everything in one. So we have our main method, and we have this array. We could create a larger array or a small array, but we have an array of so many integers that needs to be sorted. And we see that we would call merge sort, and then this code right here is just going to print the results of the sorted array. So let's take a look at the actual merge sort method, which is down here. And the first thing I want you to take a notice that we actually overloaded the merge sort method. The first method right here will create this temporary array, and that is where when we do our merge routine, we're taking the sorted lists and merging them into a new array. Temp is going to be that new array for us. So then we call this merge sort method with A, which is our original array, temp, which is going to store the merged arrays, and then we want to sort from 0 to a.length minus 1. So this is saying we're going to merge sort the entire array. This second method is a recursive method, because take a look what we have here, an if statement and 4 lines of code. That's it. So what we're doing here is instead of physically creating subarrays, we're going to actually pass the lower and upper bounds of the array. So everything is still being stored in array A. We're just passing where we're actually looking at which indices of the array are the parameters. So we're checking if left is less than right. So in this case, we're saying as long as we're still sorting, we're not down to one element or we're done with our recursion, we're going to get the middle element of our range, left and right. So that's going to be center. And we're going to call merge sort into two halves. So this is where we're splitting up the array into two halves. So the first half is going to start at the left section and then go up to and include the center element. And then the second half is going to start at center plus 1 and then go to the right. And then once we've done that, once we assume that both of these halves have been sorted, then we'll call the merge routine, which we'll take a look at in just a second here, where we're going to pass the left, center plus 1, and right. We'll see what those mean in just a second. So let's take a look at the merge implementation. So this is where the bulk of the work is taking place. So we have our two arrays, A, which has our values, and temp is going to store the merge results. Left position is going to be the beginning of the left half of the array. Right position is going to be the beginning of the right half of the array. And right end is going to tell us where the end of the right array is. Because remember, we're not necessarily dealing with exact halves of the array. We might be dealing with different portions. So we got to know where we start and stop on the left and right sides. Now you might be asking, well, where is the left end part of the left half of the array? Well, that's taking care of this first line, which is going to be right position minus 1. And then temp position is going to be used to help us out with the temporary version of our temporary. We're going to use that in our temp array, which we see down here. And then we figure out how many elements we're actually going to process. So we need to take the right end and then minus subtracted by left position, and then we add 1 to it. But that tells us how many elements we're going to actually end up merging in our temporary array. So let's see what's going on here. We have several while loops. This first while loop is actually going to compare the elements in the two arrays. So what we're doing here is think of this left position, this left array is like our array A, and this over here is our array B from our earlier example. So if the corresponding element in both arrays, whichever one is smaller, we're going to put that in the temporary array and then increment the corresponding counter indices. So we're saying this first if statement, if the element we're looking at in the left array is smaller than the right array, then we're going to put whatever values in the left array into our merged array and then increment temp position and left position. Otherwise, that means the element in the right array is smaller than the element in the left array. So we're going to put whatever's in the right array and store it in the temporary array and then increment the corresponding positions. That's what the first while loop is doing. The second while loop down here is going to copy the remaining elements of the first array or the left array. So if we get to the end of the right array and there's still stuff in the left array, then we're just going to take whatever is left over in the left array and store it in our merged array. The third while loop is going to copy the remaining elements of the second or right array and put it into our merged array. And then we have a for loop that takes everything from the temporary array and copy it back into A. So now this range is sorted in A. So when we're done with this method, A is going to give us that sorted portion of it. Now you might notice one thing right here where we actually have a comma here, and that's perfectly fine to have this. So this is saying for our update portion of the for loop, we're going to increment I by 1, and we're also going to decrease right end by 1. So this is perfectly valid code. Okay, so that's everything at the merge sort algorithm. So let's go ahead and compile it and run this code and see what happens. We'll compile it. Compilation completed, no errors. That's always good. So this is our original array. So let's go ahead and run it and see what happens. Sure enough, we get 1, 2, 13, 15, 24, 26, 27, 38. So sure enough, this does give us the result. Now I could add some lines here to actually show us what parts are being sorted, and we can break down the recursion a little bit further. But as we can see, this program does in fact sort our array.